Historical Marathon. The best episodes of Naval Legends for those who haven't seen them and those who are keen to re-watch them. At the end of Marathon, we'll publish a brand new episode about Greek cruiser Georgios Averof. Look for special codes in each and every episode of our History Marathon. As with our in-game daily shipments, all the gifts will be revealed in advance. If you're hungry for more, you'll have a chance to double the haul of gifts through your actions. If we manage to reach a set number of new subscribers within a 24-hour period, we'll double the number of gifts for the code. You can find more information on our website. Don't forget to subscribe, as there are more bonus codes to come.
This is the Supermarine Walrus, a British seaplane designed in the 1930s. By this time, aviation was largely used at sea, and Great Britain continued an active search for possibilities of further application of aircraft aboard warships. Cruisers and battleships needed to look far over the horizon.
Reconnaissance is where it all begins. Previously, the best you could achieve was climbing the rigging of an old ship, going up the mast, looking from the crow's nest, and trying to look over the horizon. By 1908, 1909, the Navy were using kites and balloons to try and extend the height of that crow's nest and that mast further still. With the arrival of the aircraft, it now gave them the possibility not only to gain height and look over the horizon, but actually move away from the ship and rove around and explore several miles away from the ship, and then bring back all of that information, all of that reconnaissance information, and use it for best tactical advantage.
Even before World War I, the British Navy experimented with ground-based aircraft in order to accommodate them for use as shipborne aviation. Aircraft would take off from a basic takeoff platform installed atop the bow gun turret or forecastle. They managed to take off, but until a certain time, no one was able to land an aircraft on a moving ship.
Squadron Commander Edwin Dunning achieved this in August 1917 with an experiment to see if he could land back onto HMS Furious whilst Furious was moving and underway at sea. To do this, he had to fly down the port side of the ship, past the superstructure, past the funnels, past all of the masting, and at the very last moment, maneuver his aircraft very dangerously in front of the island and tower and drop it onto the very short deck on the front of the ship. This was the very first time that an aircraft had actually landed on a ship moving at sea, and it's made an enormous step forward in the possibility of creating what would become the aircraft carrier.
However, a maneuver like this was an exception. Only the best pilots were able to land their aircraft on a cruiser or battleship. For this reason, in the first 20 years of the 20th century, the role of naval aviation was fulfilled by seaplanes equipped with floats, allowing them to land on water. They were launched from specially equipped vessels.
The Seaplane Lighter was another key part of carrier development. The Seaplane Lighter was a large steel hollow-hulled barge that was originally designed to tow flying boats many, many miles further than their flying range, and of course extend their flying distance. They could be towed behind a destroyer or a fast launch and deliver that flying boat anywhere that the Navy needed to operate it.
The Golden Age of Seaplanes happened between the two world wars. In general, aircraft completed missions related to reconnaissance or anti-submarine warfare. But soon it became obvious that they are ideally suited for search and rescue operations as well.
Those tasks define the development of seaplanes. What is reconnaissance? It's when the aircraft should have a great range. There were no radios on board at that time. The engine became more powerful, floats were enlarged, and the overall quality as well.
It's little known,
But in the 1920s in Europe and North America, they organized very efficient and well-advertised competitions between seaplanes. They competed for speed, takeoff, etc. And the main sports aircraft there was a seaplane.
In 2 decades, seaplanes evolved from a fragile flying apparatus to a reliable machine, able to withstand significant accelerations.
The aircraft behind me first came into service in 1935. It was built initially to fulfill a requirement from the Australians, who wanted 12 aircraft to operate from various ships that they had. But it was designed by a chap called R.J. Mitchell, who worked for Supermarine. And R.J. Mitchell, as many of you will know, was the gentleman who designed the Spitfire. And one of the things that surprised both R.J. Mitchell was at the SBAC, that's Society of British Aerospace Companies Air Show, which then took place, I believe, in Hendon in the 1930s, the test pilot actually looped this aircraft, which surprised the designer, but it was able to withstand the pressures or the stresses and strains simply because it had been built so very strongly.
Supermarine Walrus Specifications. Length, 11.5 meters. Wingspan, almost 14 meters. Maximum takeoff weight, 3,651 kilograms. Engine, Bristol Pegasus 6, 680 horsepower. Maximum speed, 217 kilometers per hour at a height of 1,450 meters. Armament, 2 3x7.7mm Vickers or Lewis machine gun. Payload, 272 kilograms of bombs. Crew, 3 people.
There was the pilot, who obviously sat in the pilot seat, the observer, the Navy's term for a navigator, and the telegraphist air gunner, who was usually the junior member of the crew. And it was his task to climb out of the aircraft, up to where I'm standing, and then on up, past the engine cowling, and up to the top of the wing there. So if you can imagine, he was sitting up on top of here, with the crane hook coming down towards him, in a very rough sea, waiting to hook it on, with that propeller going round behind him. A very dangerous job.
Each return from a mission posed some risk to a seaplane crew. When an aircraft was on the approach, its parent ship would perform a maneuver in the form of a letter S. It was necessary to create a patch of relatively calm water for landing. Having landed, a seaplane would approach the ship's side, but kept the engine running because the ship was moving, and the pilot had to control the aircraft's position until the lifting crane's hook was lowered to them.
And I'm pleased to say that my father, who was actually a telegraphist air gunner and flew walruses from HMS Malaya in the Pacific during the Second World War, was actually one of the people who had to clamber up here and get the aircraft hooked on. One of the names that this aircraft used to be called as a nickname was actually the Steam Pigeon. And the reason for that is that a lot of spray coming off the front of the aircraft would hit the heated cylinders of the engine here and give off clouds of steams.
The Walrus had a characteristic trait. This flying boat was equipped with a retractable 3-wheel undercarriage. This feature enabled the aircraft to be landed both on land and water.
It was very dangerous to land it with the undercarriage down over the water because, as they found out when it was first attempted inadvertently, the aircraft actually ended up turning upside down, flipping over. But fortunately, since the aircraft was so strongly built, it actually survived.
Shipborne aviation continued to evolve, and the range of tasks it could perform became larger, not only to spot an enemy in time, but also deliver a precise and powerful strike on them.
Ferry Aviation have been manufacturing aircraft for the Admiralty and for the Royal Navy from the end of World War I. Ferry developed its own aircraft as a self-financed project called the TSR-1 in the early 1930s. This developed into the TSR-2, which the Admiralty saw and liked and adopted and soon became known as the Swordfish.
Ferry Swordfish Specifications. Length 11 meters. Wingspan almost 14 meters. Maximum takeoff weight 4,036 kilograms. Engine Bristol Pegasus 3M 690 horsepower. Maximum speed 222 kilometers per hour.
So the Swordfish could be slowed right down to almost a walking pace to perform quite safe and careful landings.
Armament: one 7.7mm Vickers machine gun, one 7.7mm Vickers or Lewis machine gun in the rear cockpit. Payload: 3 227-kilogram bombs. Torpedo: 702 kilograms.
The Swordfish could carry a variety of weapons to deliver. Of course, the torpedo, which is what it was designed to carry, an anti-shipping 18-inch torpedo, but it could also carry mines, depth charges, small bombs, and underwing rockets. But the torpedo was its mainstay. There was also a single forward firing gun operated by the pilot. The TAG operated only a single Lewis K machine gun, so the Swordfish was very lightly armored for its own protection.
Crew: 3 people.
It's very exposed to the elements, very wet, very cold. The pilot and crew would have to be dressed and lagged in their sheepskin coats and trousers, but still the crews loved it. It was still a very maneuverable airplane. It was still very forgiving. It was the airplane that they trusted would almost always get them home, and that was important.
By the beginning of World War II, the Swordfish was considered obsolete, but nevertheless, it was used on almost all front lines. The aircraft began its service with anti-submarine patrols near the Norwegian coast, participated in convoy escorting in the Atlantic Ocean, and defended Malta. It played an important role during the hunt for the famous German battleship Bismarck, and made a crucial contribution to the defeat of the Italian Navy at Taranto Harbour. On November 12, 1940, 20 Swordfish planes took off from an aircraft carrier 170 miles southeast of the Italian naval base at Taranto. The aircraft attacked in 2 waves, 12 and 8 machines. The enemy was on the alert, and the anti-aircraft fire was quite dense. The Swordfish split into flights of 3 planes each, and having evaded barrage balloons, descended.
Almost touching the waves, the Swordfish was forgiving enough that it allowed them to keep stable and level at a very low height above the water, launch their torpedoes, and then break away and maneuver out of harm's way, all below the enemy gunfire.
Thanks to moonlight and flares, Italian battleships were clearly visible and received 6 torpedo hits. As a result, 3 battleships sank at their mooring. At the same time, the British lost only 1 plane in each wave. The lessons of that night operation were well learned by Japanese admirals, who used them during the attack on Pearl Harbor.
As well as the sterling work in tracking down and sinking the Bismarck, and of course the Italian harbour raid at Taranto, the Swordfish, during the middle part of World War II in the Mediterranean, did an enormous amount of work to sink German and Italian shipping. Swordfish squadrons across a period of 1 month dealt with more than 30 enemy ships in 1 month period, and over a 9-month period averaged destroying 55,000 tons of shipping per month for a 9-month period. That's an enormous amount of destruction on the enemy just by using the Swordfish alone.
Regardless of all these successes, the age of biplanes came to its end. By the beginning of 1942, it became obvious, no matter how good the Swordfish was, it could not complete all the necessary tasks at sea.
A very key piece of Swordfish action during World War II was the launch of Swordfish against what was known as the Channel Dash. The German fleet had been held in Brest Harbour due to bad weather and had tried to make a bolt up the English Channel to get back to their own German harbours. This was spotted, and Eugene Esmond led an attack of Swordfish out into the English Channel in absolutely atrocious gale force conditions to try and intercept the German fleet as it ran along the Channel side. Tragically, all of the Swordfish were shot down.
The reality of World War II required more modern machines to oppose the German Junkers and Messerschmitt.
At the beginning of World War II, the British had an apparent lag in the development of deck aviation. The reason for this was that the Admiralty underestimated the role of aircraft carriers. Accordingly, they did not allocate necessary funds, scientists, or resources to develop deck aviation. A little later, they created another aircraft, Barracuda. It was a British-built aircraft, and it had good characteristics in regard to takeoffs and landings from a ship's deck. The further development of aircraft was based on the designs created for the Air Force, the Royal Air Force. They just took prototypes of their own planes, modernized, upgraded, and rebuilt them to suit the needs of the Royal Navy. In other words, land-based aircraft appeared, and on their design, shipborne aircraft appeared to be used aboard classic carriers.
It was not until after the war that the air arm of the Royal Navy received a new aircraft. When batch production of the Westland Wyvern began, it was able to play the role of both an attack and fighter plane. Specifications of the carrier-borne fighter Westland Wyvern S4. Length, almost 12 meters. Wingspan, 13.5 meters. Maximum takeoff weight, 11,115 kilograms. Engine, turboprop, Armstrong Siddeley Python 3, 3,670 horsepower. Maximum speed, 615 kilometers per hour at a height of 3,000 meters.
Had power-folding wings, which, to make sure it fitted in the aircraft carrier, folded not once, but twice, because otherwise the tips would have hit the top of the aircraft carrier hangar. And it used the Ullmann flaps, which gave it a very good slow-speed landing capability and also gave it some good combat turning radius.
Armament. 4 20mm Hispano Mark V cannons, 2 in each outer wing. Payload, up to 1,360 kilograms, including bombs, mines, rockets, depth charges, an 850-kilogram Mark 17 torpedo, or suspended fuel tanks. Crew, 1 person.
So it became the first naval airplane to have an ejection seat. So the pilot in emergency merely pulled a firing handle and he was powered out of the airplane on a Martin Baker ejection seat. So the first time the pilot has ever had to do that. The Wyvern was one of the fastest propeller-driven airplanes the Navy ever operated. Over 460 miles an hour.
However, apart from attack aircraft, by the beginning of World War II, the British Navy needed modern fighter planes. In the late 1930s, the British had to catch up with Germany and go from the biplane era to the monoplane era.
Avarov was the most modern ship of the Greek Navy, and even among the navies of all the opposing countries, the reasons why she became the Greek flagship are clear.
As was common with a lot of fleets at the time, the relationship between officers and enlisted was not always idyllic. The cup of patience overflowed, however, when for lunch the crew were served this. But Naval Headquarters ordered Avarov to be scuttled on the premise that she was too old to be of military value, and there seemed little merit in giving the enemy a prize of the hero of the Balkan Wars. Avarov survived 5 wars and was originally funded by donations from private Greek citizens, and 70 years later was again rebuilt by donations from the public. Welcome to Athens.
From the first days of World War II, the Royal Navy desperately needed a carrier-borne fighter plane of the new generation.
The British Navy didn't realize the importance of aviation for naval warfare. Conservatism reigned there. In fact, they didn't even see any potential aerial targets at sea. They didn't think aviation would be useful to them. Meanwhile, in other countries, for example, Japan or the US, it was developing at a tremendous pace. This situation resulted in a paradox where the leading naval power in Europe entered World War II with outdated carrier-based aircraft, the Swordfish strike plane and the Gloster Gladiator fighter.
It wasn't until May 1940 that the British Navy received a modern carrier-borne fighter aircraft, the Ferry Fulmar. The Ferry Aviation Company produced 600 vehicles before the end of 1942.
The Ferry Fulmar is the first stress-skin, all-metal monoplane fighter that the Navy had specifically built and ordered for it. The Fulmar, as a name, as a graceful bird, a beautiful seabird that is extremely agile and is a beautiful, almost an acrobatic flying gull.
Specifications of the Ferry Fulmar carrier-borne fighter plane. Length over 12 meters. Wingspan over 14 meters. Maximum takeoff weight 4,944 kilograms. Engine, Rolls-Royce Merlin 30, 1,300 horsepower. Maximum speed, 426 kilometers per hour at a height of 3,000 meters. Armament, 8 7.7mm Browning machine guns. Payload, 8 11-kilogram bombs under the wings. Crew, 2 people.
There's the pilot, of course, at the front, and again an observer stroke navigator in the rear compartment. This is essential again for navigating across open sea where there are very, very few landmarks or referent marks to get the aircraft safely back to the aircraft carrier. The observer, situated in the rear cockpit, would have to be constantly plotting details to track their course away from the ship and, of course, back to the ship safely to recover, with the ship not being in the same position as when they left it.
The aircraft was too big for a fighter plane and had insufficient speed. In addition, the crew faced considerable difficulties when their vehicle was shot down, and they needed to leave it as quickly as possible. In this case, the high location of the tailplane posed serious danger.
Firstly, they have to get the aircraft cockpit open, which slides back, but only that far. So now the pilot has to unbuckle himself, get himself out into the slipstream of the aircraft, which is possibly as much as 150 to 200 miles an hour, and then, whilst being buffeted by that wind and slipstream, has to get himself out onto the wing and jump through the gap between the main plane and the tailplane. Now, the critical thing there is the tailplane is not going to wait for him to go through the gap. The tailplane is still coming forwards at 200 miles an hour.
It was even more difficult to leave the aircraft for the navigator. If the cabin was ablaze and the pilot had already bailed out or was wounded, the vehicle could enter an uncontrolled spin, and the navigator's odds for escape were slim to none.
Fortunately, there are very few recorded problems other than getting out, because adrenaline works wonders. If you have to get out, you'll do things you normally cannot achieve.
Regardless of all the Fulmar's shortcomings, it received an enthusiastic welcome in the Royal Navy. For 9 months, World War II ravaged Europe, and the new fighter plane could not have come at a better time.
It took part in air cover support for work in the Mediterranean and the defense of Malta, as well as doing fighter reconnaissance work for the Bismarck raid ahead of the Swordfish, and also for the Battle of Taranto, again in the Mediterranean.
From March 1941, the British Royal Navy began to receive US carrier-borne aircraft under the Lend-Lease policy, a program under which the US supplied its allies with everything necessary to support their war efforts. At the same time, Great Britain continued to design and create their own aircraft.
Because we have limited resources compared with America, we design airplanes that can do more than one task. They're designed for a specific task, but they're adapted to do others.
The Royal Air Force performed excellently during the Battle of Britain. Even the Hurricane, which was quite obsolete compared to the German Messerschmitt and inferior to it in terms of specifications. It was still a good and reliable fighter plane, which pretty much allowed them to defend Britain. And in wartime, under the conditions of limited funds and resources, they just took this Hurricane and rebuilt it to be used as a carrier-borne plane. However, when Allies got closer to the enemy shore, so to speak, that's when they needed a more reliable fighter. Again, they took a land-based aircraft, the Spitfire, and upgraded it to be used from carriers under a new name, the Seafire.
Specifications of the Supermarine Seafire F Mark 17 carrier-borne fighter. Length 10 meters. Wingspan over 11 meters. Maximum takeoff weight 4,300 kilograms. Engine Rolls-Royce Griffon 6, 1,850 horsepower. Maximum speed 636 kilometers per hour at a height of 3,900 meters. Armament: 2 20mm Hispano Mark V cannons, 4 7.7mm Browning machine guns. Payload: 1 227-kilogram bomb under the fuselage, or 2 114-kilogram bombs under wings, and a suspended fuel tank under the fuselage. Unguided rockets: 8 RP-3 rockets. Crew: 1 person.
The Seafire was an extremely effective and useful aircraft once airborne, but during the takeoff and landing on a ship was incredibly difficult. Often difficult enough on a land-based airfield, the Spitfire undercarriage can be vulnerable enough on a rough landing on a land base, but even more so on a ship with a heaving flight deck that may be raising up 20 or 30 feet during the swell of a ship's flight deck rising. The Spitfire undercarriage was proving to be quite a problem with its narrow track and its quite small design and size and strength when it became used as a flight deck aircraft.
However, the aircraft was constantly upgraded. Further models featured more powerful engines and contra-rotating propellers for the latest modification.
By the end of the Seafire development, it was an extremely useful airplane once it was flying. And airborne, it was every bit as effective as the RAF were finding the Spitfire to be during the Battle of Britain or any of their major air offensives. Superb handling aircraft, loved by the pilots once airborne.
Simultaneously with the work on a new fighter, British engineers were designing an all-purpose carrier-borne aircraft. Their efforts resulted in the Ferry Firefly, which entered service in 1943. Specifications of the Ferry Firefly FR-1 carrier-borne fighter. Length over 11 meters, wingspan over 13 meters. Maximum takeoff weight 6,759 kilograms. Engine Rolls-Royce Griffon 2B, 1,735 horsepower. Maximum speed 509 kilometers per hour at a height of 5,200 meters.
This one was done by people, manually fold. There was no power. It took 20 people to get the wings from their present folded position into the flight position so the aircraft could take off. That took time. It took time also, once the pilot had landed the airplane on the flight deck, to get the aircraft back into the folding position so it took up less space or could go in the hangar. Again, 20 people, very manpower intensive. A crew of 2, but at least 20 people on the ground so you could actually operate.
Armament: 420 Hispano-Suiza Mark II cannons in wings. Payload: 2 454 kilogram or 227 kilogram under wings. RP-3 unguided rockets. crew 2 people.
And they also enjoyed the fact they had someone to talk to in the back. Single seat flying over the sea was not something pilots often enjoyed, because they had to also track where they were, finding their ship, returning again was often really quite difficult.
When designing this fighter, British engineers considered all the faults of previous models that were causing crashes during takeoff. A plane needs a strong headwind to successfully take off from a ship deck. To achieve this, the carrier would turn towards the wind and accelerate to a maximum speed. With favorable wind conditions, 2/3 of the deck length was enough for the Ferry Firefly to take off. It would accelerate and take off without even reaching the ship's bow, with about 60 meters of spare distance.
If the ship could not generate sufficient wind, and they normally wanted something like 35 knots of wind over the deck, then in fact they had to use a catapult, which in those days was a hydraulic mechanical catapult, hydraulic ram, lots of wires and pulleys, and it went off.
The faster takeoffs and landings happen, the better. Independent takeoffs allowed for a new launch every 10 seconds, while the use of a catapult slowed this process down to 1 minute. When landing his plane on a carrier, the pilot was assisted by a landing control officer, who signaled instructions from the ship's deck with the help of paddles.
When the batman crossed his arms, the pilot merely closed his throttle, and if he got it right, his hook, which is the first part of the airplane to actually touch the deck, would catch one of the wires across the deck, and he'd be brought to a halt from 100 miles an hour to zero in about 200 feet. He would then have to raise his hook and be taxied forward to actually keep out of the way of the airplane behind. They landed on with a worked up ship about one every 45 seconds.
Several modifications of the Firefly were created. A deck fighter plane, a night interceptor equipped with a radar, which was cutting-edge technology at that time, and a very good strike aircraft.
A lot of pilots named their aircraft, usually with a girl's name. This one is no exception. Evil in Intentions. It's a play on words. If you say it quickly, Evil Intentions, which is exactly what the pilot hoped his aeroplane was actually achieving. We also, on the side of the airplane, have a map of Japan. One of these airplanes was the first British-built and designed airplanes to fly over Tokyo towards the end of World War II, when the raids were starting on Tokyo itself before Japan surrendered.
New aircraft successfully operated in the Pacific Ocean, providing support for Allied landing operations in North Africa, escorting bombers which attacked and sank German battleship Tirpitz in the Norwegian fjords. However, war is war, and losses were inevitable. Not only new vehicles had to be built, but also new crews had to be trained.
It was better and safer to train pilots outside the country. And there was a great training pipeline in Canada and in America and in the West Indies, which people loved going to because the weather was lovely and it was in wintertime normally when they went out.
It was impossible to use real carriers for training, and future pilots exercised on special airfields that were the size of a flight deck.
Ashore, he had 3,000 feet. On the ship, he had about 300 feet. Ashore, he had a 150-foot wide runway. On the ship, he had about a 50-foot runway. So everything was miniaturized, and he had to be a lot more accurate, a lot more skilled at getting himself back on again. So as well as lining himself up, he had to ignore what the ship was doing under him, otherwise he would actually never get back onto the deck.
The Sea Fury became one of the last propeller-driven planes used by the Royal Navy. It was a high-speed aircraft designed to defend carriers and their escort ships against air attacks. Specifications of the Hawker Sea Fury FB Mark 11 carrier-borne fighter plane. Length over 10.5 meters. Maximum takeoff weight 6,522 kilograms. Wingspan almost 12 meters. Maximum speed 724 kilometers per hour at a height of 6,100 meters. Engine Bristol Centaurus 18, 2,560 horsepower.
The shape of the wing they needed, you couldn't get people to fold it. So they gave the pilot a hydraulic little device. He'd press a button in the cockpit.
Armament: 4 20mm Hispano Mark V cannons. Unguided rockets, up to 12 RP-3 rockets. Payload, up to 907 kilograms. Crew, 1 person. Usually the Sea Furies were launched with the help of a hydraulic catapult, because carriers' flight decks were too short for it to gain the necessary speed and take off with a full payload. If there was a catapult malfunction, additional rocket thrusters had to be used. These were mounted under the wings and activated by electrical ignition.
Sadly, often that didn't happen. They went over the side. And there are 2 known cases of airplane going over the front when the RATOG kit didn't work at all, and the pilot sitting in the cockpit watching the airplane go over, the ship go overhead before he decided to get out and get himself rescued by the attendant destroyer.
However, the service run of the Sea Fury was quite short. Engineers were already working on modern jet engines. New technologies allowed them to improve airplane dynamics, the system for flight control, and make vehicles more powerful and maneuverable. A new age of deck aviation began.